Okay, well, congratulations. So this is your last week of lecture, at least as an undergrad student. So, is this? I think this is recording. Okay. All right. Well, yeah, it's kind of crazy. How are your final projects coming along? I just have people nodding, nodding their heads. Like, I guess that's. What? Nodding is better than shaking your head. Yeah, that's true. So I'll take that as a good thing.
Do you have like a rough sense of like how long the report should be?
How long should the report be?
Or like each section of the report or something?
I don't know. I get it. No, I don't. But yeah. I don't know. I guess I think I said the data description part should be kind of the background information should be a couple pages long, and I gave some guidelines there, and I put that in because a lot of people did well last quarter, and last quarter was the first time we did it, and then our spring quarter, and then a lot of people did well, but then some people just wrote like 2 paragraphs in there, and I thought, oh yeah, this is not. This doesn't cut it. So, yeah, as far as the data exploration, I guess I just want you guys to kind of, see if there's anything interesting, okay? Don't just make a single histogram or, a single bar chart. But the exploration part, you should see if you can start exploring possible relationships between some of the variables, okay? So if you look at one variable and it's categorical, you might, then decide to split it based on another categorical variable and see if those proportions change, right? Like, so I feel like this is just a very, very quick review of just our things related or not, but basically if you create one bar plot and it looks like this, okay, this is for everyone, and then if you then split it by another variable and you create like a side-by-side bar plot, and it looks like this. Okay, and so this is, so whatever this is, like A, B, and C, and then if this is A, B, and C, and then you have is group 1 versus group 2, is the ABC variable related or not related to group 1, the grouping variable? Based on this plot. Not related, right? So the ABC variable is not related to the grouping variable. Because I don't know what's going on here. Because the bar plot looks the same for group 1 and group 2. Okay? If they were related, there would be a difference. Okay? So, when you have something, sorry, I'm like freehanding on this vertical surface so everything looks terrible, right? If you have something that looks like this, okay, then yes, certainly they are related, right? There's some kind of association, okay? So I mean that's just a categorical example. And then if it's numeric and you create a histogram, not related, your histogram would be like the same, right? So this is group 1 and group 2. So this is independent. If this is your variable x. And then if there is a connection, then you would expect the two to look different, right? So you might have this histogram over here, and then right, something like this, where the mean of is over here. So you have a shift in means. For group 1 and 2. So this is some kind of association. All right. And I think these are the kinds of things I would like you guys to explore in your exploratory data analysis, right? See if does it look different for this group versus this group, or something, question.
So is your definition of related there being a difference?
Yeah. I mean, related, basically, if we're saying, are two variables independent or dependent, okay, so I guess related here would just be like dependent, indicates that, right, because if we have the probability of x given y, if this is just the probability of x, then x and y are independent, right? But if they're dependent, x given y will not be the same as x given y complement or something, right? And so this is, how do you write not independent? I don't know what not independent, what the symbol for that is. So basically, yeah, if they're not equal, if they're different, if the distribution of x is different for group y versus group y complement, then yes, there's a relation. There's x and y are dependent. Versus if the distribution of x looks the same for group y versus not group y, then they are independent. Okay, and so that's one way to think about it, right? So, if we said, is broadly speaking, is like your SAT score related to gender? Not really. Okay, in general, maybe slight differences, but the distribution of SAT scores for at least for high school males and high school females look kind of similar. Maybe there's slight differences and stuff. Okay. Overall, I mean, well, okay, maybe that's not a good example there. But if there's something else like is body weight independent of gender, then the answer is generally no, in that in general men in general weigh more than women, and so the distribution of weight looks different for the two groups, type of thing. So okay, well, anyway, I think these are the kinds of plots I would like to see in the exploratory part. Of course, there's interesting things to see in individual for individual variables, but I think it's interesting to see what kind of relationships you might explore, and then if you do see relationships, then this would be an indicator of what kind of variables would you want to include in your model, as far as ones that are able to help you predict, make predictions based on the output variable. Okay. You might need to create some variables based on the variables that exist, right? You might have to, you might have a numeric variable, and you can do a scatter plot between two numeric variables. That might be interesting. But it could also be interesting just to kind of, partition your numeric variable, right? Like, is there a difference in, I don't know, the percentage of people who smoke, based on age, right? And is there a huge jump at age 18 or 21 or whatever, and things like that. So, okay. Is that all right? I don't know. Other questions? And again, if you're not sure, or if you need some help with ideas for what to do for your project, don't hesitate to make a stop during office hours. Okay. I thought we'd take a look at some SQL stuff in Python. And there is, okay, I was debating whether or not I should talk about like setting up your own SQL server, and I've decided against it because it's a huge headache. And so, this is not a class on like database administration and things like that. So we're going to just pretend that your interactions with SQL will be with a database that already exists. And I think that's a mostly safe assumption for you guys. And so what you need to do is be able to execute, SQL queries and things of that nature, and not necessarily learn how to create a SQL database from scratch, okay? There are a few resources out there. So here, I got recommended exercises, and then another place to just practice SQL queries is SQL Fiddle, I think. Where do I have it? SQL Fiddle. Oh, I'll go over here. Yeah. Okay. But SQL Alchemy is kind of the package that, or library that we might, I don't know, I think makes everything easier. There's lots out there. And then out there's something called the Chinook database, okay? So back in the day, there was something called the North Winds database, and I guess Chinook is the name for North Wind in one of the indigenous people's languages. I forget, but okay. So anyway, it's just kind of a sample database. You can just download it from GitHub, and they have it in like all of the different flavors of SQL. But we can just use SQLite. SQLite is the nice thing about SQLite is it's kind of included in Python, so you don't have to like set up a separate like MySQL server or something like that, an Oracle SQL server or something like that. You can just open up the SQLite database within Python, and it will kind of be set up and established for you. Okay. A lot of times, well, I don't know. Okay, so anyway, we'll import pandas, and then we'll call SQL Alchemy, and we'll just do something called create an engine. Okay, and then the and so I have the database file saved in my directory where I'm working on the Jupyter Notebook. Okay, and so you'll need to download the thing. You can just search for Chinook database on GitHub, and this will appear. You download the file, and then you just use SQL Alchemy to create an engine. Okay, and so the engine is kind of the way Python. You have commands in Python that get sent over to the kind of the SQL server that then performs the executes the commands and then returns back what it finds. Okay. And that's it's going to be pretty typical. Okay, it's just as far as your create engine goes, it might be different depending on if you go to a company, they might say, all right, we have our Oracle database server running over here, or we have our whatever SQL server that they've got running, and then they'll have some way to access the connection there. Okay, so anyway, we establish a connection, and then you can kind of just check to see if the connection works, right? And so one of the things we can do is we can so I've created the engine, and I'm calling that engine, okay? But you can name it whatever you want. And then I'm going to say, okay, from engine, let's pull the table names, okay? And we have all of this, okay? If you look up the help, the documentation for SQL Alchemy, there's quite a bit of stuff, okay? And because it gives you all sorts of options. There's kind of its core setup, and then it's I forget the other side, the user side setup. But here, I think just for simplicity, we're going to just kind of create the engine, and then we'll just take a look at some of the commands that we can run for SQL. Okay, so anyway, you call ask for the table names, and we can see we have the albums and artist and customer and employee table and all sorts of stuff. Okay. And so with the engine, if you want to run a query, you'll have to open up a connection. Okay. And so we'll do that with the engine.connect. And then we'll ask for the, we'll have it select everything from the table album. Okay, so this is the SQL command. So SQL is not case sensitive, okay, when it comes to the stuff, but there's just kind of a trend that the keywords you write in all caps, and then the table names and stuff you write according to how it's written, but it's not case sensitive, so I could leave it in lowercase and whatnot. Okay, so anyway, this just says select everything from table album, so just return everything from the album, and then we would ask. So this is the query, and then here we can say fetch all. Okay, so you can tell it I only want the first row, or I only want like the first 3 rows or something like that. In general, we expect fetch all, okay? So this is kind of the query result, and we'll fetch all, and then we're gonna feed this into a pandas data frame, and then once we're done, we close up the connection, and then we'll print out the results of our query here. Okay, and so we get back 5 rows, and it's just the names of a few songs or a few albums, and I'm not entirely sure what this column thing is. Okay, if we wanted to, you can also ask for the keys, and so oops. Okay, so album ID, title, and artist ID. Okay, so this is the artist number is this third column here. Okay, so if you ask back for the keys. Okay, we can, instead of having to manually open the connection, execute the thing, put it into a data frame, and then close the connection, you can use a command called with. And then this will, here we say with engine.connect, and what this will do is it will create the connection and then close it when it's done. Okay, so engine.connect, and then so here I've just kind of put everything, exact same commands, execute the command, fetch all, put it into a data frame, and then we're going to name the column names what we extracted from the keys. Okay, and so here we can write our command and we can put it in triple quotes. And triple quotes in Python allow you to have multiple lines in whatever text it is that you're running. Okay, so like SQL will execute this just fine. Okay, but to make it a little bit more readable for humans, we often will have the keyword, the SQL keyword, kind of in all caps and start off these things. Okay, so select it will say tells it which columns you want. Okay, so here I want the columns last name and title, and then from, and you give it the table name. Okay, select chooses the desired columns, and then from indicates the table to query. Okay, so this is just going to select the last name and the title from the employees table. Okay, and then by assigning the keys to df columns, we'll get this. Okay, so we have Adams as the general manager and Edwards as the sales manager and stuff like that. Okay. All right. There is, and even faster than that is you can do pandas read SQL query to make things even easier for you, and you just give it the command, and then you tell it how do I establish a connection to a SQL database. So you give it the engine. Okay, so these have already been established, right? So we have the engine as create engine from SQL Alchemy. And then the command here is what we last used, select last name and title from employee. Okay, and so here we can just say, do this, right? Read from pandas, read SQL query. And so this makes it real easy, and it will also assign the keys to the columns of the resulting data frame. Okay. So this is probably kind of the quickest way as far as getting data out of a SQL database. Okay, is you set up your engine and then just use pandas read SQL query. Okay, as far as if your relationship with the database is just to query it to pull information. Okay, I don't know if we'll get to it, but your interactions with the database might be to start writing to the database and adding entries and things like that, and then then that's different. But if your relationship with the database is there's lots of data on these servers, and I just need to pull the information, okay, if you're just doing an analysis type of thing where I just want to extract the rows I want and summarize it and look at relationships and things like that, then this read SQL query where it's just kind of a read-only relationship with the database is probably more than sufficient. Okay, so now we can start order by is basically the same as sort. Is SQL's version of sort. Okay, and so here my command is going to be select everything from employees, order by birth date, and then we'll just have pandas read it in. So here it's pulling all the columns from the employees table, and it's sorted from birth date here. Okay, and then just like everything else in you can say SQL order by, and then you can say, well, how do I do descending? And then probably your first hit will be this, and you can then specify whether you want it ascending or descending, right? So you just kind of, and then there are different kind of flavors of SQL, but a lot of them there's a lot of commonalities. And so if you try something and it doesn't work, so here we do descending, and that seems to have worked. You can try other things. You can type in SQL Lite and see if you get something more specific. But in general, all of these things you'll find out there. This is a great site, the W3 Schools for the SQL. I mean, this is kind of just web-based stuff, and so anyway, this is how you'll say it, right? Select your columns from the table name, order by, and you can specify multiple columns that way. Maybe I will include okay, so there you go. Where is kind of the if statement, filter row selection with where, similar to using if as a Boolean mask. Okay, so it's going to be here, select all the columns from employee where employee ID is greater than 6, okay, and employee ID is this first column here, and there we go. Okay, so it pulls out just rows 6, 7, and 8. Okay, and you can combine additional things. So you can have employee ID and title is equal to IT staff. Okay, and one thing to get used to is the it's a single equal. If you want it equal to something, it just SQL uses a single equal, not the double equal. So that's okay. So we have that. All right, I guess we can just go through some of the stuff. You can do joins. Okay, so we can look at data across multiple tables using a join. Okay, and so we can do all right, so we'll do album join on, oh geez, let me just kind of, okay, from inner join, okay. All right, so we're going to select everything from album, and I'm going to do inner join on, so we're going to go to, so the album has album ID, title, and artist ID, and then so now I'm going to go to the artist table, and we're going to join on inner join artist on artist ID. I think that's the oh, okay. No, this didn't like it. All right, let me just see. Select everything from artist. Let me just, okay, so I have artist, oh, ID has is lowercase. Okay. Inner join on artist ID. Okay, I gotta probably do, oh, on album. Inner join artist on album.artist_id equals artist.artist_id. Is that gonna do it? Okay. All right, so you have to fully specify out the thing. Okay, so here we're saying select everything from the album, okay? So, oh boy, this is really long, okay? And so here we're matching, did I only do the head of album back here? Oh yeah, I only did the head, okay. So, you know, if we look at the album table, so if I just select everything from the album table, it looks like this. Okay, I've got 347 rows. Maybe we'll just, you can do limit 10, all right? So this will give us back the first 10 items. And then here, it pulls the same 10 albums, okay, but then it goes to the artist table and it looks up and it matches them based on the artist table, okay? And so, you know, AC/DC published, for those about to rock, we salute you, and let there be rock, and it matches those, and it has those accordingly. Yes?
How do we drop the artist ID columns? There's just one.
So it's just one. It's a good question. Customer ID, so here we go, and then inner join on this. I don't know. Do I have to specify album ID, title, and then we'll do name? Okay. So I think you can specify just the columns that you want, but let me just see what happens if I do artist ID without specifying. Yeah, it complains. I can say album.artistID. But yeah, when you do the inner join, by default, it will return both of them. And then And I guess you can kind of manually name the columns you want. I don't know, is there a better way to do this? Let me see. Remove duplicate column from inner join. All right. How to deal with duplicate columns in case of full outer joins in Magic ETL. I don't know what Magic ETL is, but perform full outer join, connect the join, attach the select. Okay, that's not helpful. Let's see what Stack Flow says. Okay. The duplicate columns we usually ask. Okay, so the answer is type out the column names that you want, which is not, maybe not be pleasing, but
Yeah,
I guess
if
it.
you have, like, a lot of columns.
Yeah, if you have a lot of columns, it could be annoying, but that appears to be the. How to remove redundant column, let's see. So we have this, and then okay. Yeah, I guess there's not like a clean, elegant answer. It's just type out the names of the columns you want. Sorry. Okay. Yeah, and if you and then I guess without I didn't specify this, but you know, there's limit, which is kind of like head, x like head, okay, and limits the number of entries it returns. Okay, so anyway, you have that. Okay, and then there's and then you have group bys. So here we can do so we'll select oh man, do I want count album ID from album inner join? Okay, I have to look at my help. So here, I want to do group by artist ID. Okay, so we're going to select artist ID, name, and count album ID, and this didn't like it. Okay. From album, group by artist ID. Okay, so this is kind of like your aggregation feature, and this will go through. And so here I said select artist ID and the name, and then count the album ID, and you can and you can name this as counts or something. Album count. Okay, so you can aggregate this. So this is kind of your aggregation function, and here we are joining the album to the artist table, and then we're grouping it by the artist ID column. Okay, so it's kind of like your group by thing. Okay, so here, so you have this, and then here you can do limit 10, so you just have a few. And so this will be kind of all of the, so AC/DC published 2 albums, and Audioslave published 3 albums and stuff like that, at least in our database, okay? And we can kind of, you know, try to verify this if, you know, is this true? We can do select order by artist ID, and then if we run the query, run 10. So yeah, indeed, even if I sort it by artist ID, okay, yeah, we see that there's 2 here and 2 here and things like that. Okay, I guess 15 or something like that. Okay. All right, so that's that is the group by, and then if you want to put a conditional on the group by, conditionals on group by, you can't use a where. Okay, so conditionals on the group by must be done with having. Okay, so here I've created up here we said, you know, here's all the artists, and this is how many albums they've made, and here we can say having album count greater than 8 or something like that. Okay, and so this will just return artists that have over 8 albums. Okay, and so this is different from where, because now this is the result after you've done the group by. Okay, so the where filters the original rows before it does the group by, and then after it does the group by, and if you want to do any kind of filters on the results, you have to use having. Okay, so here Led Zeppelin has 14 albums and Metallica has 10 albums and things like that. Okay, whereas if you wanted to use a where, I don't know, I'm not sure as far as the tables go. Album artist, I don't know, what is in the track table? Okay. Again, let's just select everything from track. Album ID, I guess these are just individual, this is the actual tracks from each, oh boy, okay. Each track in the available in the data set. Okay, so I guess, you know, you could join this on something, but maybe I don't want to do that right now. Okay, I don't know. This is just very, very, very brief intro. If you want to learn more SQL, I do think I'll provide links, but W3 Schools has a good good kind of a reference to the basic and common SQL commands, and then I'll link some additional things. Yeah, the SQL exercises are also good. Okay, all right, we'll end there, and then we'll see you guys on Wednesday.